Hello everyone, good morning. Welcome back to my channel Learn Take with Kiran. In today's session, we will discuss about context-free grammar generation for palindrome string. In previous video, we already discussed about context-free grammar, its definition and where it is used. Let's start session with concept of understanding what is mean by palindrome and how can we generate context-free grammar for palindrome string set. Okay, now is mean by palindrome? Then palindrome is a nature of word or a number or a syntax that reads the same whether it is read from a left to right or a right to left. Okay. Now palindrome can be single word, entire sentence or a number. Okay. Let's take an example for a better understanding. Here you can see words, numbers and sentences. These are palindrome. If you read this from left to right or right to left, these are same. Hope you understand what is palindrome means. Now the point is how can we design context-free grammar for those type of words. Before that we have to generate context-free grammar for two type of palindrome string in this session. One is palindrome string with a even length of string. Other one is a odd length of string. Okay, let's discuss both of them one by one. In university exam, questions are asked like this: construct a CFG to generate a set of palindrome over alphabet A and B. Okay, this is same question asked for a number also. Now we have to design a string for a even length. Okay, so we have to construct a grammar for a even length. That's why we are designing this string for even length. Okay, this is a set of string. Let's generate context-free grammar one by one using recursive pattern. Okay, here you can see these are a string which is generated from A and B. Okay, now AA, BB, 4 times A, 4 times B, then AB, BA, BA, AB. Okay, so similar like this you can generate more string also. Now for this we have to generate a context-free grammar. Now first one is a. For this we can use A S, which is nothing but a initial symbol, and A, and I can explain you afterward why we generate this grammar also. You can represent this AA as similar like this also string starting point, and directly you can put AA or BB for a this string. But why we use epsilon? Because at some time you can generate this string by using this also with the replacement of epsilon. Okay, so whenever you want to epsilon, you can put this also. So that's why we generate first initial grammar with a epsilon only, not with a AA and BB. If you want to generate with AA or BB, it is also correct. Okay. Now for a AA, what I write? AS, which is nothing a starting symbol, then A. If I replace this S with a epsilon 1, so it means it generate a AA string over here. Okay. Now let's discuss another one which is a BB. Now, you can directly write this also, but we can use epsilon because it is a memory efficient for us. Okay. Now for BB also I can write grammar similar like this. So here you can see B, your initial symbol S or a non-terminal symbol S and B. So here non-terminal symbol will be replaced by your terminal, which is nothing but a epsilon. Then it will generate a string BB. Then next one is a 4 times A. For this we can use same this grammar as a initial one and construct this. So basically what we do over here, we initiate your string with a starting symbol or a non-terminal. We use initial as a, your non-terminal symbol S and A. Now here I am giving you 2 because these are some expression we generated for a your grammar. Okay, so I am using over here second expression. So I initiate A, your non-terminal with A. Now your non-terminal S will substitute with again expression number 2. So that's why your string is become AA, your non-terminal, then again AA. Okay, so here I am using a second expression, correct? Then I have to replace my non-terminal with a epsilon because I get my whole string which is nothing but 4 times a. So that's why I replace this non-terminal with a substitute epsilon. Now let's discuss next one, which is 4 times b. For 4 times b string generation, we use a third expression continuously as we use a second expression for a this one. Okay, I hope you understand this. Then next one is a abba. Okay, w is stand for a string. Okay, now abba for a generation, this what I use a starting or a initial expression is your second expression because I want to generate abba. So where I can get 2a in a second expression, correct? So I can use this expression as a initial one. Then I want to substitute with a b, so that's why I substitute this s with a bsb, which I want to complete my string, so that's why I substitute this s with a epsilon, which is my first expression reference. Okay, so that's why I take a reference of first expression and substitute my s with a epsilon, and I get my string which I wanted to generate. Now similarly baab string also generated with the help of sequence third expression, then second expression, and then first expression. Okay, I hope you understand. Now you can see over here your lastly generated all strings are in even length. Okay, I hope you understand this. Therefore the requested grammar is mentioned over here, and our production rules are like mentioned in this grammar, which is nothing but first expression, second expression, and third expression. Okay, you can see your grammar is in the form of context free grammar tuple. I hope you understand this. Let's discuss another problem statement, which is nothing but your palindrome string over alphabet a with odd length. Our length of a string is a odd. Okay, so we have to generate a grammar for this. Okay, so as per our first production rule, we can see over there we use a epsilon over here because we want to even string. Now whenever you go to design a odd string length, you have to substitute your epsilon as a, or you're starting as a. Okay, because you have to generate a first string as a. So that's why I use over here this one. Then next one is a b. For b you also have to directly substitute your starting symbol with a b, because you can maybe generate only a or only b as a your odd length string. Okay, now these both production rule help us to make palindrome string in odd length. Okay, let's move forward with the next string, which is nothing but a triple time a. Okay, so basically what we have to do, we just initiate our string as a. Okay, with a non-terminal value s. Okay, so you can substitute this s as a expression 1, you can see over here, and your string getting as per your language set. Okay, so for a triple a you can set your grammar like this: a, your non-terminal, and this non-terminal will be substituted as per your first expression. Now same logic we can apply for a b string. Okay, so when we want to describe a grammar for a bbb, we can use b, your non-terminal symbol s, and b, and we substitute this non-terminal s as a your second expression reference, which is b, and you can generate your b or a triple b string over here. Okay, then next one is a abba. For that you just use your third expression as an initial one, and then you want a b as a middle symbol. So you can replace this substitute or this non-terminal with your second expression, which is nothing but s tends to b, which means you substitute your s as a b. So that's why I'm using second expression as a reference expression over here, and I generate my string as mentioned in my language set. Okay, or a string set. Now this similar logic will be applied for your bab string. Now what you can do over here, you use directly fourth expression as an initial expression as we use here third. Okay, then for a you used one expression for a reference as we use over here 2. Okay, so basically for a bab your expression is 4 and 1 over here. Okay, let's discuss next one, which is nothing but a b b b a. Okay, so we have to generate a 3 times b and a. So for this, by using this same grammar, we can generate the string, correct? So basically what I use third expression as the initial one because I want start my string as a. Okay, so that's why I substitute my initial or a non-terminal with a third expression, which is nothing but a, your non-terminal s, and a. Then what I need next, which is nothing but a b. So from what I get a b, from a expression number 4, that's why I substitute this s or this non-terminal with a fourth expression. Okay, so here you can see a remains same, your s will be substituted as a bsb, which is your fourth expression. Okay, so after that I want b as a middle one, so that's why I use second expression as a substitute for a b. Okay, so similarly you can generate a, b, b and a. So basically what you understand from expression 1, 2, 3 and 4, from this grammar we can generate all odd length palindrome schemes. Let's discuss one more example, which is BAB AB. Okay, so for that what we have to do, we have to substitute our S or initial state or initial symbol S as a BSB, as we wanted a starting with B. Then I need A, so that's why I have to substitute third expression as a S, so that's why I use a third expression as a substitute for a S. Then I need a B as a middle one, so I substitute my second expression as a S. So that's why here you can see my reference expression over here and the string is generated. From this we understand we can generate any of a string with odd length by using these 4 expressions. So that's why your production rules are something like S tends to A or B, which is first and second expression, correct? Then your third expression is A as A and fourth expression is a B as B. So by using this you can generate any string which is a odd length for a palindrome string. Okay, then here you can see your tuples from a grammar. S is nothing but your variable or a non-terminal. Then these are your terminals or a symbol, your production rule, and then your starting point. I hope you understand this. So this is how you can generate a context-free grammar for any of your context-free language. Okay, I hope you understand. That's it for today's session. I hope you understand the concept and implementation of context-free grammar. In next video, we will discuss one more solution for a problem related to the context-free grammar. I hope you found this video helpful. Don't forget to like this video, share with your friends and subscribe my channel. Thank you.